Because it is the natural color of the sky. It is given to the earth by its blue colors. That's why when you look at it from the earth, it's like it's reflecting the water from below. That's what
because of the water that reflect the light, the clouds to the sun.
Okay. So, hindi naman talaga blue yung sky eh. We just see it just because yung blue kasi, di ba, siya yung may shorter wavelength. So, ibig sabihin, siya yung mas nagsascatter. So, siya yung nakikita ng eyes natin.
Because of the visible light coming from the sun.
For me, the sunset is red because the sun has, the colors of the sun are not fully shown anymore. It's only giving off the only colors it can be that are visible anymore, which is of course the color orange, because the color yellow can also not be seen anymore.
They reflect siya from to the sea. Orange plus blue ba yun? So it's the red.
Dahil sa pollution. So, kapag mataas yung pollution, yung rate ng pollution sa air, so mas nagiging darker ang color ng sunset.
The light is seen red. It has a long wavelength.
The sun will be going down.
After rain comes, after a rainfall, then when the sun comes up, it's like the color that is left from the rain is mixing with the sun in the air, creating a rainbow. Yeah, is that enough? All from the colors left from the rain and the sun.
Thank you.
Because the reflection, it releases all the color.
Ulan or ambon. Tapos kapag biglang uminit, magkakaroon ng rainbow.
Reflection ng light sa mga water vapor, kaya siya na
Droplets which breaks the white light into 7 visible.
the rainbow form usually after the rain. I think in every problem has another name.
Do you think that our eyes have a natural inclination towards blue as compared to violet? Yes, this is one of the reasons why our sky appears blue and not violet. To understand this, first, let us study about Tyndall effect. Tyndall effect is a phenomenon in which a beam of light scatters on striking the particles present in its path. This scattering of light is responsible for the blue color of the sky. We know that our atmosphere primarily consists of oxygen and nitrogen particles, along with dust, smoke, and other particles in comparatively smaller proportions. The size of these particles in the atmosphere is responsible for the color of scattered light. When the sunlight strikes particles of dust, smoke, etc., which are bigger than the wavelength of sunlight, all the colors of sunlight are equally scattered. As a result, the scattered light appears white. However, when the sunlight strikes particles of oxygen and nitrogen, which are smaller than the wavelength of sunlight, the colors of sunlight having shorter wavelengths, that is, blue and violet, are much more scattered than colors having longer wavelengths. But our eyes are much more sensitive to blue color as compared to violet. Hence, the sky appears blue to us.
Light must pass through a greater distance in the Earth's atmosphere, causing it to pass through more particles. As a result, most of the blue and violet light gets scattered before they reach our eyes. Due to this, the less scattered light like red or orange reaches our eyes, making the sunset appear red.
Hold on, guys.
A rainbow is formed when raindrops split sunlight into different colors. Sunlight, or white light, consists of many colors. However, only a few of them are visible to us. A band of these visible colors is called a visible spectrum. When we see a rainbow, our brain and eyes distinguish the visible spectrum into 7 main colors, namely red, orange, yellow, green, blue, indigo, and violet.
Light is a strange thing. It isn't just what we can see. Light can be broken up into different types, and we call the whole family the electromagnetic spectrum. So even when it's dark, light is still all around us. Light can be created by making an electron oscillate. This creates an oscillating magnetic field and an oscillating electric field, which we call an electromagnetic wave or light. We often represent light as a wave. Just like water waves, light has a wavelength, a frequency, and a speed. The different colours of optical light have different wavelengths, and so does the rest of the electromagnetic spectrum. Gamma rays are the most energetic, whereas radio waves have the least energy. Even so, light is the fastest thing in the universe. In a vacuum, all light waves, even radio waves, travel at an incredible speed of 300 million metres per second. The Roy Observatory is overrun with squirrels. They're hard to miss during the day because they reflect visible light from the sun, but at night it's more difficult. However, they do emit infrared light, and if our eyes could detect it, we would be able to see them in the dark. If we pass high-energy X-rays through them, the squirrels look very different. Humankind has invented lots of different instruments to show us what our eyes can't see, like our Great Equatorial Telescope, which captures huge amounts of light and allows us to see objects that are tens of millions of trillions of kilometres away. We can see matter interact with light and change it. The gases in the Earth's atmosphere scatter blue wavelengths of sunlight, giving us blue skies during the day and red skies at sunrise and sunset. We can watch sunlight reflect off planets and the moon. During a lunar eclipse, red sunlight changes direction as it passes through the Earth's atmosphere and reaches the moon. And although visible light from stars can be absorbed by dust in space, we can detect the infrared light, which gets through to see baby stars hiding in nebulae. Light can even appear to stretch out. Since our universe is expanding and galaxies are moving away from each other, the light they emit is stretched to longer wavelengths. We call this redshift. Some galaxies are so far away that their light has shifted and stretched from visible to infrared, so we can no longer see them. Stranger still, the universe has unknown amounts of dark matter and bizarre black holes. So even if we can detect all the different types of light, there are still some things in the universe that will remain invisible to us.